This video will focus on some simple demonstrations that can be done in the classroom to illustrate what goes on in the core of a massive star as it goes supernova. The supernova occurs after a core of iron is produced. Fusion reactions are still occurring in the onion skin-like structure around the iron core, but there is no energy production in the core itself to support the weight of these overlying layers. The iron core's temperature rises until the energy of a photon is sufficient to break apart an iron atom. Suddenly, all of the iron nuclei are destroyed in what astronomers term a photodisintegration. The iron that was supporting the overlying material is gone, and the outer layers fall toward the center of the star. These layers bounce off each other as they meet at the massive star's center. The astroblaster is an inexpensive tool for illustrating this. It consists of a stack of balls threaded on a central rod. When dropped, one can think of each ball as a layer in the collapsing massive star. If we simply drop the small red ball, note that it does bounce since it is made of rubber, but it doesn't bounce very high. However, if we stack all of the balls on the central rod and drop the stack vertically, our red ball travels off at high velocity. The energy of the blue balls bounce, and the green balls bounce, and the yellow balls bounce are all imparted to the red ball. This is a good analogy for what happens to the layers of a massive star as they bounce off of each other at the star's center after the photodisintegration of the iron core. The astroblaster has some disadvantages as a demonstration. The red ball is small and travels off at high velocity, so it is hard to see, and it is difficult to drop the stack of balls exactly vertically, so often the red ball is shot off in an unintended direction. An apparatus with similar demonstration goals consists of an aluminum slotted frame where discs of different size fit in the frame. A stack of discs is dropped in the slot, and again the smallest one on top is shot up at high speed as the discs bounce off of each other. The discs are easier to see, and spectators are unlikely to be injured as the small disc always travels upward vertically. If we simply drop the small disc into the slot, we again get a modest bounce. However, if we drop a stack of discs, our small disc on top travels off at high velocity. When astronomers view supernovae remnants, they often see chaotic debris spreading out, while a black hole, or neutron star in the case of the Crab Nebula, is left behind at the core. More teaching materials can be found on the web at astro.unl.edu.